Hey everybody, welcome to week 8, the last week of Chem 2. I'm pretty stoked. I hope you are too. Today, we're going to make kinetic sand, and then we're going to talk about how/why the kinetic sand works the way it does. So what I've got is some sand. I ran down and got some. Cornstarch. We're going to use a tablespoon of that cornstarch and mix it in with the sand. And then I've got some water. I went ahead and heated mine up just to make it dissolve the soap, the dishwashing soap, faster. And then we'll mix in that dishwashing soap with our cornstarch and knead it all together, right? So it makes sense. So again, like we said, here is a tablespoon cornstarch that I'm going to mix up. Pretty easy. No big deal. It's really kind of anticlimactic. So what I'm going to do is I'm going to go ahead and mix all this stuff up, and then we'll come back on live and discuss why this stuff works the way it does. Okay? So, like I said, we're going to mix it all up, and I'll get past the all the boring stuff and come back to you. Put you on a quick pause for now. Alright, so we're back. I've kind of got everything mixed up, much like the demo video. I think I put too much liquid in here, so we may try some other methods. But I'm going to talk to you a little bit while I'm stirring this up, and we're going to... So what is kinetic sand? Kinetic sand, obviously, is a trademark toy. My son has some somewhere around here, and you typically get it in different colors, and it molds into really kind of any little desired shape you want, but it doesn't stick to anything other than itself. And it's basically like wet sand, only it doesn't dry out. And a lot of this is because of the silicones that are in the mixture, right? The polymers. The molecules are basically these chains of repeated units, and these polymer chains with the silicone oil that we get kind of or make with this, they make the sand particles stick together so that you can form them into a ball, and then slowly over time, it doesn't just hold its shape forever, right? Like slowly over time, this kinetic sand or these sand particles that are stuck together with these polymer chains and silicone oil, they will just kind of flatten out and go back to their normal shape. But they'll forever stay, in theory, they'll forever stay together and never dry out. It is not dangerous. It's not unhealthy, unless I guess you eat it. That would be pretty unhealthy. But this is kinetic sand is an example of a non-neotonin fluid that increases its viscosity under stress. So the more you squeeze it and the more you mold it, the more it just kind of holds up, right? So here is my kinetic sand. And the more I squeeze it, the more stress I place on it, the more it oozes out. But if I just leave it, I've still got this ball. So we'll scoop some more up so you can get a better visual again of how that works, right? So if I squeeze this, it just kind of oozes everywhere. I'm making a mess on Tim. My wife's going to be mad. But if I just let it be, it's this ball, and I can mold the ball up and do what I want with it, right? So that's kind of the coolness of kinetic sand. Now, the one last thing I want to talk about is this is week 8, the last week. So I appreciate you sticking with all my videos and my ridiculous questions as we've gone through the last 2 months together. And that really kind of wraps it up. I had a good time in this class. I appreciate it. Make sure you do the patriotic thing and grade on a good curve. And I appreciate everything. Maybe I'll see you in organic chemistry. Bye.